All right, guys, here we go. Guys, today we're going to talk about the second part of 5.2, like we just talked about, stuff we did yesterday. All right, we already talked about it. Stuff we did yesterday, we said was going to be a little bit easier than what we do today. What's the reason for that? We just talked about this. Yeah, y was already by itself yesterday, Kyle. Good. Today, we're going to have to get y by itself. All right? So situation one, which was, we just talked about this. There was no rearranging. X or y was already isolated. It was all set to go. We could just plug it in. Now today, all right, situation two. So you have situation two on your notes, all right, where today we're going to have to rearrange, all right? We're going to have to isolate or get by itself x or y on the left-hand side of the equal sign. Yesterday it was already set up, one of those equations was already set to substitute. Y equals 2x plus 3. That was already set to go. Today you're going to have to rearrange one of those equations, all right, to get x or y by itself. All right? And remember, guys, I know we drilled it in your head, slope-intercept, y equals mx plus b, y equals mx plus b. If you can get x by itself, when we do these, that's okay. All right, if you can get x by itself, that's fine. It doesn't have to be, you don't have to get y by itself every time. If it's set up and you can just move something to get x by itself, that's okay. Because we're not graphing it. We did graphing on Monday. We're not doing graphing with this stuff. So if you can, there's an opportunity to get x by itself, you can do that. You don't have to worry about y equals mx plus b, but if you're going to get y by itself, I would suggest when you move the x, move it to after the equal sign, so it follows the same format. It's good practice. All right, everybody good with this? I'll leave it up here when I go down. All right. Here's a couple of reminders, and we covered these when we did our warm-up today. All right. First thing, and we did this in the warm-up. The first problem we did in the warm-up, we had to get y by itself, was just like this. All right, we have x on the same side as y, but there's no number attached to the y. Like the first one we did in warm-up. Like it might look something like this. We'll say 2x plus y equals 5. X is on the same side as y, but there's no number attached to y. That's the first, so this is one way, one situation we're going to look for to get y by itself, so we can substitute. So we're going to take an extra step today. We're going to move some numbers or variables around to get it set up so we can substitute. So what this says is shown right here. So what we're going to need to do, it's already written on your sheet. All right? You're going to do the opposite operation of x. So we would subtract x here, subtract x here. We're going to move it to after the equal sign, so over here, then just rewrite it out. So it would be y equals negative 2x plus 5. And that right there, I'm all set to substitute. Y is by itself, I can substitute now. So that's one situation. X and y on the same side, no number attached to y. And that's just one step. Move the x, bam, it's done. Guys, don't worry so much about that. If you didn't, you don't have to write down the example. If you did, that's fine. If you didn't, that's okay too. We did one like it in the warm-up. Now, another situation where we have x on the same side, like up here with y, but now we'll have a letter attached to y. So it might look something like this. Oh, number, I'm sorry. So guys, when you think this, wait, it doesn't matter, you'll get right this in anyways. It might look something like this. 2x plus 2y equals 4. X and y on the same side of the equal sign, and unlike up here, I have a number that's attached to y. So this is going to involve a little bit more work. Our first step will be exactly the same as we did up here. We want to isolate that y first. So I have minus 2x minus 2x. And I'll get 2y equals negative 2x plus 4. Remember, in order to move it, I'm giving it its opposite sign. To move it to the other side, I give it the opposite sign. That's what allows it to be moved. All right? So that's what it says right here. Do the opposite operation of x. It was a positive 2x, so I subtracted. And I moved it after the equal sign. There it is. Next step, and we talked about this in the warm-up, divide everything in the equation by the number attached to y. All right? So for this equation right here, I'm going to divide everything by the number that's attached to y. So Jordy, this equation, I want to divide everything in the problem or in the equation by the number attached to y. So what's attached to y? What number?
2.
2. What am I going to divide everything by? 2. Divided by, and that's what's attached to y? That's what I divide everything by. It'll look like y equals negative x plus 2. Y is by itself. So that's 2 steps. All right? X on the same side as y, number attached to y. Now another thing. If there's a negative, all right, if there's a negative sign only attached to the y, that means there's a negative 1 attached to the y. So you're going to make sure you attach you're going to divide everything in the problem by negative 1. So after I move something around, maybe it looked like negative y minus 3x plus 1. I would divide everything by negative 1 because y is not by itself yet. It would be y equals 3x minus 1. Negative and negative gives me the positive, and then positive divided by a negative is a negative. So keep that in mind. If you have a negative attached to the y, you're going to make sure you divide everything by the negative 1. I don't think we had any more steps. All right? So again, that's this. And don't worry about the examples, guys. If you wrote those down, great. If you didn't, that's okay too. So those are a couple of reminders or things we have to remember when we're trying to get y by itself. All right? So let's go on to the steps. So steps to solve linear equations with substitution. All right? Now in situation 2, where we have to rearrange. When it's not y equals something anymore. It's not x equals something anymore. You're going to have to move some stuff around. All right? So first step. I know it's quite a bit to write. I'm sorry. So we're going to choose the equation to rearrange that already has a single variable. All right? So it's x. It has x. You look at both equations. You say, okay, that equation has just a y. It might be like 3x plus y equals 7. That's got a y only. That's probably going to be the equation I want to use because x or y has no number attached. All right? Now, if both equations have a single variable, I would choose the equation, if it's possible, that has the positive single variable. Say one had a negative y and one had positive y. No number attached, it's negative y or positive y. I would pick the equation that has the positive y. All right? Reason being is, remember, if there's a negative number attached to the y, at the end, I'm going to have to divide everything by negative 1. If I pick the one that has a positive y, I eliminate that step. I don't have to divide by a negative 1 to make the y positive. All right? Then we'll rearrange the equation using the reminders. All right? The two situations, or the two things we talked about before we get to the steps, like when x was on the same side as y, right, and y didn't have a number attached, or when x was on the same side as y and y had a number attached. You've got to remember those things to get y by itself. All right, and then we're going to kind of put our parentheses. All right, so I'll give you guys a second to get this written down, because I know it was kind of a little bit long. And then we'll go, this like we did yesterday, we wrote our steps down. We'll go through, we'll do a problem. That's after each step, you'll have an example of that step for a problem. All right, so guys, today, this is going to be the only new step. All right, and you'll see once we get done with this step, everything else we do is the same as yesterday. So this is the new thing, getting x or y by itself. Everything else we do after this is going to be the exact same things as we did, the exact same steps as we did yesterday. We're just adding this part. All right. I'll give you guys the same number because I want you guys to pay attention to these. It'll still be up there. All right. So here's my system. Based on that step we just wrote down, which equation would be better to rearrange? The top one or the bottom one? Which equation do we think would be better to rearrange? Top or bottom? What do you think, Liam?
Bottom.
Bottom. Why do you say bottom?
Because it's a positive.
All right, it's a positive. What else? Josh? Yeah, the variables alone, right? The y, there's nothing attached to the y. I have a single variable. I have a y. I got a 9x here, that doesn't work. I got a negative 2y there, that doesn't work. All right? I have no x down here, that's okay. That's not always going to happen. All right, we might not always have an x. All right? So we're going to use the bottom one because y is already by itself. Good. Now, think back to those reminders that we talked about. Is this going to be the first thing that we talked about, or the second thing that we talked about in those reminders? First thing or second thing? The first things we wrote in class today. It's going to be the first thing, the first situation, or the second situation? Or the first type or the second type? Shannon? Okay, so you're telling me that there's a number attached to y?
No.
All right, I got to move the 4, right? So I'm going to...
So wait, you want that to be a 4x?
Yeah, let's make that a 4x, Mr. Hager.
I don't know how it's going to work out, but... Yeah.
There we go. We'll make it a 4x. All right? So we use the bottom one. So there's not, the x and y are on the same side, but there's no number attached to y. So that means only one step. What do I have to do? Someone tell me. What do I have to do now? Ashley Aldana, what do I have to do now to get y by itself? One step and one step only. Subtract 4x. Perfect. Very good. Subtract it on the other side. Ashley A, what's my new equation? Now it's rearranged with y by itself. What's it going to look like?
Y equals 4x.
Careful.
Y equals 16.
How did I move that? How did I move that x?
Negative. Yeah, negative.
So what should it say?
Y equals 16. That, yep.
All right. So I just remember. Even if you said 16 minus 4x. It's a mistake. Okay. Even though you could have said 16 minus 4x, that's okay. But like when we've done slope-intercept, we've always put the x right after the equal sign. So when we get y by itself, try to stay in that habit. All right. So now I'm done. All right, I'm done that part. So do you want to change something? 19. All right, so guys, the top one. All right, just change the 2 to a 9. That way, Mr. Hager just did the quick math. It'll work out. Will it work out? Okay. All right. So make sure you change the 12 to a 19. All right. Now we've rearranged. Now the steps we do after this are going to be exactly the same. So does anybody remember from yesterday what that first step was? What the first thing we had to, because now we got it, we're not worried about this anymore. This is done. That's my new bottom equation. Liam,
Put parentheses
where?
around where you're gonna substitute
All right, so what am I substituting?
for y or x.
All right, so what am I gonna put? I'm gonna,
You're gonna substitute
what am I putting, tell me what I'm putting parentheses around.
what y is equal
Yeah,
to and the y.
yeah, so I'm gonna put parentheses around this, right? So like Liam just said, all right, we wanna put parentheses around the variable, the information after the variable that's isolated. Let's go down. So, rest of the steps are the same as yesterday. Like Liam just told us, put parentheses around the isolated variable in the other equation and plug in the information that already has the thing. So, already has the parentheses. So I go back up here, in the top equation, what letter should I be putting parentheses around? In the top equation, what letter should I be putting parentheses around? Emma? Why? Because it's isolated down here. Good, Emma. So I put parentheses around that. So that's once we rearrange, it's the same as yesterday. All right? So I'm going to put the parentheses around the isolated variable in the other equation. So once I get my whatever equation I choose, once I get it rearranged, just like I did yesterday, the information after it, put parentheses around it. Then, put parentheses around what letter you're going to substitute that information in the other equation. All right? So now, I've done that. I got it all set up. I got parentheses all set to go. What's the next thing I do? Same steps as yesterday. What do I do now? Say it. Yeah, put 1 in for y, Kyle. Yeah, the minus 4x plus 16. Plug it in for y in the top equation. It's like Mr. Hager's writing in. So I'm going to go down here. I left some space here, guys, but we already did that anyways. We already wrote in up here. We put our parentheses. We did all that. Now we're on step 3. Like Kyle just said, we're going to solve the equation with the parentheses, the isolated variable that has the parentheses. I'm going to plug the information in. Same as yesterday. It should only have one letter. You're either going to have a couple of x's or y's. You can't have an x and a y. It doesn't work that way. All right? And like we said yesterday, we may have to use the distributive property. Most times we're going to have to do that. Most times we're going to have to use the distributive property. All right, so I'll let you guys get this copied down, and then I'll bring down that problem. What was it? Y equals negative 4. What was it, guys? What was the top one? Oh, there it is. So 9x minus 2y equals 19. 9x minus 2y equals 19. And the other one was what? Y equals negative 4x plus 16. Okay. Y equals negative 4x plus 16. And we already did all this. We did this. We did this. We did all that. So now, and Mr. Hager already drew our line. He did that. All right? He's highlighting. So I'm plugging into the top equation. I'm plugging that information in the top equation. What is my top equation going to look like? What would it say? What would it read? Kyle?
9x minus 2 parentheses. Negative 4x plus 16 parentheses equals 19.
There we go. All right? So now we're going to solve. Same steps as yesterday. All right? First thing I want to do is what? Distribute. Nothing I can do with the 9x. Just bring it down. What am I distributing? What number? Marissa, what number am I distributing? -2, good. I like how you put the negative. Remember, the sign to the left's gonna go with it. I'm distributing that. KD, what's the first thing I'm gonna distribute in? I have -2 to what number inside the parentheses? -4x. When I do that, what do I get? Positive, very good. I'm multiplying. 8. Perfect. Very good. So that's me distributing this. Next thing I'm going to distribute. Somebody, how about Trenton? What's the next thing I'm going to distribute? -2 into.
-4.
I already did that. What's the other thing inside the parentheses? Yeah, +16. All right. So -2 and +16. Anybody know? Anybody know? Positive and negative, -32. All right? Equals, I'm just going to bring down the 19. Next step, same step as yesterday. Who can tell me?
Combine like terms.
Good, Kyle. Combine like terms, CLT. Hannah, what are my like terms? 9x and 8x. When I combine them, what do I get? 17x. Needing to back up. Next step, same as yesterday. Anybody know? Anybody know? Dominic? Next step? Starts with an I. Isolate. Right? Isolate the variable. Because it could be X or Y. I'm going to isolate the variable. Natalie, do you know how to do that? Huh? Okay. No. I want to get on this side. I just want 17x. I don't want anything else. So if there's something on that side with it, I want to get rid of it. Add 32. Good. What am I going to add 32? What am I going to add 32 to, Natalie? 19. This cancels out. I'm going to get 17x equals 19 plus 32. 9 plus 2 is 1. All right. 11. I'm going to carry the 1. Now I'm going to get 51. Last step is what? Divide. Divide by what number, Ashley? 17. Divide by 17. Divide by 17. X equals, if I grab my calculator, I'm looking in the wrong spot. And we'll do 51 divided by 17, 3. X equals 3. All right? So I don't care if X or Y is isolated, X or Y you have to rearrange. I don't care. These steps, once you get plugged in and you do your substitution, these steps are always going to be the same. Distribute, combine like terms, isolate the variable, divide. Always going to be the same. I don't care what kind of problem you have. All right, now, just like yesterday, we're going to plug the number you solved for. So here, we plugged in, right, we solved for 3. We solved x for 3. We're going to plug it into the other equation. I want to plug it into the equation that I rearranged. All right, I want to plug it into the equation that I rearranged. All right, I'm going to plug it in for x or y, depending on what variable I solved for first. In this case, what variable did I solve for first? X. I solved for x. And like Mr. Hager said, I always want to go back to the one that I rearranged. Or if it's one where it's already been isolated for us, then I want to plug it in for that. Why do I want to do that? Why would that be a good idea? Because if I plugged in the 3 up here, then I'm going to get 9x minus 6 equals 19. Then I got to add 6 and move to the other side. If I plug it in here, all my work's going to be on one side. I'm not going to have to move anything. I'm just going to, if I plug it into my calculator, I'll get the answer. I'm not going to have to move a number because it'll be whole numbers on one side and just the variable on the other. So I'm going to get y equals, what's it going to look like on the other side? Kyle?
-4 parentheses 3
Oh, sorry. -4, parentheses 3,
plus
plus 16. Y equals negative 4 times positive 3. Negative 4 times positive 3. Negative 12. Plus 16. Y equals, I think I heard somebody say it, 4. So, last step. Answer should, when we write our answer, it should be written like this. It should say x equals 3, comma, y equals 4. Or, I mean, if Mr. A and I can see that you circled them and not in that order, that's okay. But from the multiple choice on the test on Friday, that's how the answers will be written. X equals 3, y equals 4. They'll be written like that. So the one you have to pick. All right. If we have a short answer on them, you write it in like that. That's okay. As long as we can see, as long as it's circled, we're fine with that. So, what's the only step that's different from yesterday and today? We got to rearrange, right? And Kyle, I heard you say it. We got to get y alone. Or if x is already if it's like x plus 2y equals 5, get x alone minus the y, and you're all set. Sometimes you may be able to get x by itself. You might see that in one of our examples. All right. So the only thing that's new today is we have to rearrange. Everything after that with the parentheses and stuff is all the same as yesterday. Rearranging is the only new thing.
All right, so let's take a look at 2B. And this is one where you really have some choices. Okay, there's different ways to do it, and I think there's a couple ways that could work out pretty easy. If you pick the top equation, what letter could you get by itself? You could do y or x. I would argue one of the two letters in the top equation is a little easier because it's already positive. X. Okay, if you want to work with the top equation and get x by itself, you could. Or if you want to work with the bottom equation, what letter would be easy to get by itself there? Y, because it's got a 1 in front of it and it's positive. So this one you could do either way. So you guys tell me, you want to work with the top equation to get a letter by itself, or you want to work with the bottom? Bottom? Okay. So we're going to work with the bottom. We just said we're going to get y by itself. How do you get y by itself in the bottom? You can tell me just one step. It would have been one step if we did the top two. Yeah, subtract 2x, subtract 2x. Okay. And once we do that, Emily, can you tell me what does y equal?
Y equals negative 2x plus 4.
Perfect.
You guys, I mean, a good habit might be too. Once you rearrange this is done. This equation right here, this 2x plus y, it's down here now. You changed it. Don't worry about that anymore. You can cross it out or whatever you want. It doesn't matter.
So what I like to do, so now I remember, is I just take the other equation I didn't use and just copy it down.
And that, the other one there, the 2x plus y equals 4, that's gone. You already rearranged it. Don't worry about that anymore. If you want to cross it out, you can.
Okay, so now I kind of jumped ahead a step, but I put my parentheses around what was after the equal sign.
Yeah.
What else should I put parentheses around? The y. How about the negative with it? Should I put the negative? No. Just the y. Right. So now, what am I going to do with all the stuff that's inside the parentheses up above? We're going to plug it in
Remember where y was, because it won't be there anymore.
right there. What's going to happen to the x minus? That's just going to stay there. Nothing's going to happen to that. Now, we're going to replace y with, what am I going to replace it with? Yep, good. Negative 2x plus 4. What else do I need to write? This equation's not done yet. Equals, yep, I still have negative 4. Okay, on this left side, there's no number in front of the parentheses, but what number can you pretend is there when you just see a minus? Yeah, it's like a -1. Okay, so that, what I just circled, is what needs to be distributed. Jordy, what's -1 times -2x? Well, how about what's -1 times -2? Forget the x, just -1 times -2.
Times?
Times.
I don't know.
Joey, how about a negative times a negative?
And then we turn it to a positive.
Correct them unknown. So what's one thing that Mr. Hager can write up there for sure?
No,
A
positive.
positive sign, right? Now you get the positive. What's 2 times 1?
Times what?
Yeah. Not add,
Oh.
multiply. 2 times 1 is
2.
2. There you go. You got it. He's just gonna make sure he puts the x, that's all. You're okay, you got it.
And Kyle, I saw you had your hand up too. Can you tell me the next part? -1 times +4 is -4. Okay. So now, what do we do next? Usually there's an abbreviation.
Maggie, do you know?
Story
What's due
rights.
next? If you're not sure, look back, we're at the same spot we were when we did on the front. The steps are exactly the same. So after we distributed, we did what?
He usually writes
Yeah,
three letters.
Some mistake. And what are your like terms? Yeah,
On the left-hand side.
no. X plus 2x minus 4. What are your like terms? And? X and 2x, right? So when you put those together, how many x's do you get? Yeah, well, you have 1x and you have 2 more x's. How many do you have total? 3. Yeah, 3x.
Okay, so we just combine our like terms. Now, what's the next thing we do? Josh? Yeah, we're going to isolate the thing that has the x with it, right? And how would you do that?
You add 4.
Can you say it again?
Add 4.
Add 4, yep. So we're going to add 4, and Josh, can you tell me what happens there? -8? Okay, everyone agree with -8? 0, yeah, the same calculation you just did right here. -4 plus 4. Well, -4 plus 4 is 0. So now my last step, or if you can think in your head, 3 times what gives you 0, that's your answer. But yeah, go ahead. Yeah, we can divide both sides by 3. So what is x? 0. Okay, so x is 0. On the test, if it's a short answer, just make sure you circle it. So when we look at it, we know where your answer is, because there's a lot of work with these problems. Okay, x is 0. Sai, what do I have to do now? Well, we're still on this problem, but there's one more part to it. What's the next part in this problem? Yeah, take the x, plug it back in. Now, I'm plugging it back into the equation that already has y by itself. If I don't, I can still get it right, but it's going to be more work. So plug your answer back into the equation that already has the y.
Yeah, the one you rearranged, the one you changed.
So now off to the side here, I'm going to find y. Y equals, and somebody give me my calculation that I need to do to find y, and plug in what we just found for x. Okay. -2, right? Because that's, so we don't change that, it's -2. Yep. 0, so she just filled in what we had for x, and we need one more thing. Plus 4. Right, so what's -2 times 0 plus 4? What do we get? I heard a few different answers. What's -2 times 0? That part is 0. 4.
And guys, if you plug in your calculator 2 with the parentheses 0 plus 4, it'll give you the answer too. You just plug it in.
All right, so any questions on that? Solving that system. We have 2 of these and then a word problem?
I think so, Mr. Hager.
All right, let's, we'll probably come back. I think we'll have time to do 2C or 2D. We'll do one of them. But let's look at the word problem. Okay, because the word problem's a little tricky because you have to set up an equation and then solve it.
Yeah, you have to set up the system.
Okay, so anytime you have a word problem, the first thing you want to do is figure out what are the 2 things that they're asking me about. Are they asking me about like student tickets and adult tickets? Are they asking me about 2 different clubs, drama club, yearbook club? Just figure out what the 2 things are they're asking you about, and give those 2 things variables that make sense to you.
And guys, there's no real space on your notes for this, but if you want to write it in, you can. Or if you want to just listen, that's fine too. You're not required to write this down. There's no spot on your notes for this.
Okay, so if I'm talking about like a drama club, I might use D to remember D for drama. Or if you want to use X and Y, you can, but I try to pick a letter that makes sense. Yearbook club, I might use the letter Y. That might be a good variable. And then we're going to look for some keywords in the problem. Okay, you might see the word total. So when you see total, like if you total things up, what operation is that in math? Josh? Addition. So if we see the word total, we think addition. Sum also means addition. Less than, okay, or fewer than, okay, you'd see subtraction. So I can't list every possible word you could ever see. There's tons of them. But we'll go through it and see if we can figure out our 2 equations. All right, so it says there are 64 students in a drama club and yearbook club. Okay, and I think that means together. If you take all the students in the drama and all the students in yearbook and add them up, there's 64. The drama club has 10 more students than yearbook club. Okay, we're going to write a system and then figure out how many students in each club. All right, so let's start with the 2 things that we need to find. Can somebody tell me one thing that they want me to find here? What are they asking me to figure out? Okay.
How many more students the yearbook? Yeah, how many, the amount of students that yearbook club has?
Yep, that's one thing, the amount of students in the yearbook club. So let me write that. So I'm just going to put yearbook club. And what's the other thing they want me to find? Yep, Nini? Well, that's what we're going to set up to find the other thing that I'm asking for. So this is not the only thing they want.
What other club is mentioned in the problem?
Someone said it. Yeah, we're looking for the drama club. Okay, we don't know how many students are in either club right now, so we have to pick letters. Okay. What would be a good letter for the number of students in the yearbook club? Yeah, this would be a good case. You could use Y. And how about drama club? Yeah, we could use D. Okay, so now we know how many students in, well, at least we have it represented. Okay, let's look at the first sentence. There are a total of 64 students in the drama club and the yearbook club. What does that mean? A total of 64 students. Yeah, go ahead. Yeah, all together. So when you find out all together, how do you do that? Like arithmetic-wise? Yeah, what would be the 2 things you would add up? And if you did, you would get a total of 64 students.
The number of kids in the yearbook club and the number of kids in the drama club.
And how many are in yearbook club? Or at least, how did we represent it?
Y.
Yep. So we'll take the amount of students in the yearbook club, plus how many are in drama? D. So take amount of students in drama, and that's our first equation.
You guys, usually that first equation gonna be based on the total. Maybe the total amount of money that you made, total amount of tickets that were sold. Right, that first equation is usually gonna be based on the total. It's usually gonna have single variables like it does there. Now, if we're talking about like money, like an adult ticket costs $10 and a student ticket costs $5, you might put those numbers with the variables. But in this case, we didn't give us any money values, so we just leave them as single variables.
So can now somebody tell me, you don't have to give me the equation, but tell me what sentence in that problem is going to help me next. Okay? Can you read me the second one? The drama club has 10 more students than the yearbook club. All right. Anybody think they know how we can come up with a equation from that? The drama club, another way to think of it is the drama club is 10 more than yearbook. And I put the word is in there because if you think is, that might give you a hint. Sai?
You could divide 64 in half, then take half of the number you got and add it on to the other one.
I'm not sure, where'd you get half from in that
Well,
sentence in blue?
It says drama club has 10 more students than yearbook club.
Okay,
If you were to divide 64 in half, you would have half of the number. Then if you were to take 10 from one half and add it on to the other, you would have the students.
okay, but would that set up a system? That would give us our answer, but would it set up a second equation? No. So there's always ways, like if you're clever, you can reason it through because you're going to get,
So I'm gonna say that would work.
yeah. But in this case, they specifically asked us to solve a system. So if you got the two answers, I give you half credit for getting the answer, but not for setting up the system. So how do we set up that second equation? Think of it as drama club is 10 more than yearbook. Think of it that way. Drama is 10 more than yearbook. Yeah?
Y plus 10b equals 64.
Let's write it like this. So drama is 10 more than yearbook. Okay? What's drama?
D.
D. D. What does is mean? No, of means times. Is means equals. The drama club is 10 more than yearbook. So how would you write 10 more than yearbook? Emma?
D equals y plus 10.
Yeah, exactly. That's your second equation. That's the first one. That's the second one. The drama club is 10 more than the yearbook club. Okay? Or you could say yearbook club increased by 10. It's the same as saying 10 more. Okay, now we're at the point where we can solve it. And this kind of problem you would have seen on the homework last night. Okay? How come this is easier than what we're doing today once you already have the equations? Okay?
Because you don't have to like rearrange it.
Yeah, how come one of the equations, which one is already set up the way we want? The bottom one. What is it solved for? D. So we're going to take the bottom one, which is already solved for D, and Kyle, where are we going to plug that in? The D where? Yeah, above. We're going to plug it in right there. Okay, so it's a little bit easier. We don't have to rearrange anything. Right, so can somebody tell me, if we do what Kyle just said, what will my new equation be? It won't be y plus d equals 64. Please? Yep, y plus, yep, y plus 10 Perfect. Do I have anything I need to distribute in this problem? On the outside of parentheses? No. I don't have any number here other than a 1. So we can just take the parentheses out. So there's nothing to distribute. And Maggie, what do I do next on the left-hand side?
You already did this. We asked you about the same step earlier.
Combine like terms. Can you tell me what my like terms are? Y. And what else? So you're saying you're going to combine this one with what else? You have to combine it with something that it looks like. Y. So y plus y. Okay. Sabrina, can you tell me y plus y? 2y plus 10 equals 64. Somebody else? How am I going to move a plus 10? Yep. Subtract it from both sides. So now you might be starting to see what some people were saying. Take the 64, subtract 10 from it, and then, what did they say to do after that? Divide it by 2, which is exactly what happens when you solve the system. So what's 54 divided by 2? Can use our calculator if we need to. It should come out to 27. So what does that mean? 27 equals y. What's 27? Yeah, that's how many students that are in the yearbook club. Now there's one other club we still have to figure out. What's that one? Drama. Well, what did we just say y was? 27. So we're going to take what we just got for y and fill it in. So how many students in the drama club? 27 plus 10, or 37. Okay. And if we add those up, 37 and 27, that's a total of 64 students. And one club has 10 more than the other. Okay. So any questions on that, setting up the equation?
On that last slide, it's being time to practice either one of the ones we can do.
You want to put it in the video? Yeah, let's put that in the video. At least set it up. All right,
Let's set it, let's have them send it out, and then we'll solve it. That's a good idea. Then they can solve it on their own.
Okay, which equation here should we work with to try to get a letter by itself? Which one do you think? The bottom? What letter would you get by itself in the bottom? Y, I agree, you could do that. What else could you do, and I think it would be about the same amount of work as getting y by itself in the bottom? Yeah, get y by itself in the top.
Guys, why does Mr. Hager say that it's probably going to be about the same amount of work? Why would he say that? Okay, it's a 2x on the top, 3x on the bottom. What else? It's a 2x on the top and a 3x on the bottom, right? Why would it be about the same amount of work? Meaning? Okay, both y's. Careful, almost. It's kind of like that, one of those special cases we talked about earlier. We know that we'll rearrange. We're going to rearrange the equation that has y that's positive. But in this case, it has y as a negative. All right? So there's still going to be 2 steps there. You're still going to have to do 2 things. All right? Why are you going to have to do 2 things? Even though you don't really see it there with the y, what's really there? A 1, right? There's really a negative 1 with that y. If it's positive, it wouldn't matter. right, where it's negative, and both of them have a negative y, it doesn't matter which one you pick.
So what are the two things Mr. Roy was just mentioning?
What two things you have to do to get y by itself?
Careful, if we added 2x to another 2x, we would get 4x.
Might subtract.
Yep, we want to subtract it, because that'll make it cancel out. But y still isn't by itself. I have negative y. What do I do now to get y by itself? This was mentioned, I think, in your
One more
steps.
step. Because y is not by itself yet. Easily? Yep. Divide the whole thing by -1, because even though it's not shown there, there's still a -1 with that y. If it was positive, it wouldn't matter. If we divided everything by a +1, it'd still come out the same way. That's why we don't do that when y is positive. But when it's negative, we have to do this.
And what does dividing everything by -1 really do? It could make things positive, it could make things negative, it depends, but in general
Just keeps it all keeps.
no, it doesn't keep things the same. Dividing by anything by a -1 will cause what to happen to it?
The opposite.
Changes what? Change the sign.
I said two opposite.
Okay? It's going to become the opposite. So if you had negative, it becomes positive. If you had positive, it becomes negative. Okay? So now we have y by itself. What would we do with that? Put it in, what's the other one? Top one or the bottom one? The bottom. And when you fill that in, what do you have to be careful about? What's on the outside of the parentheses? A negative. So when you fill everything in, leave that negative because that has to be distributed. Jordy, can you tell me what I get when I do -1 times 2x?
Negative times positive. Negative times positive. Yep. So negative, right? Then -1 positive 2. I'm not happy. You told me it's gonna be a negative, right? So I'm gonna say it always be a negative up there, right? And then 2 times 1. 2 times 1. 2, isn't it? Yeah, you're right.
And then a negative times a 5 gives me -5. Maggie, what would I do at this step? Yeah, combine our like terms. Can you tell me on my left-hand side, what are my like terms here? Yep, 3x and 2x. And if we subtract, what's 3 take away 2? 1. So we're left with that. And what's nice here is when we combine our like terms, we have just an x.
Yeah.
So now we're at our last,
Eliminate a step at the end.
yep, last step. What's my last step? Add 5 to both sides. So what's x? 6. Last step, fill x in right there. So we have 2 times, what did we just say x was? 6. 2 times 6, and then plus 5. Shannon, what's 2 times 6? 12. And 12 plus 5 gives me an answer of, that's my y value. Okay, so remind Mr. Roy and I, what do you have to bring tomorrow? Chromebook.
It's on that last page, I think, too.
Why do you have to bring it? Because the MCAS question. What's on Friday? Test? What's special about it?
It's the only one on the
It's the only one on the progress report. Yep. Okay, so homework tonight, Mr. Roy's passing it out. It's worksheet 5.2,
5.2.
part 2.
I have a 5.1.